In order to completely understand about the working of the differential, like first of all, let me tell you about the simple working. Halima, just wait for 3-4 minutes. I'll be finished
Yeah,
with
I've
this.
seen many videos, but I still don't understand completely.
Okay, see,
It gives me
basic,
a very weak
basically,
understanding.
basically the thing is that suppose there's a problem. Like when a car takes a turn, the inner wheels it covers a small
Yeah,
distance than the
small
outer wheel.
distance, larger. The
Okay,
larger wheel
so
covers a longer distance.
so imagine you're like imagine running on a circular track with your friend. So if you're on the inner lane, you cover less distance than your friend on the outer lane in the same time. So similarly, in a car, the inner wheel rotates fewer times than the outer wheel during a turn. And if both
So it needs
wheels
to be
were
at a lower RPM.
yeah, so if both wheels were forced to rotate at the same speed, like
The
like a
rotor
solid
would break,
axle without hmm.
skidding,
Okay, na? So like the
skidding
inner
and
wheel
rotor
would
brake.
exactly very good. Like it will slip or skid. It will cause the tire to wear. It will you will lose the handling and you will lose the control. Okay, na? So the solution is differential. It's a arrangement of the gear that splits the power of the engine between the two driving wheels. It allows the wheels to rotate at different speeds while still transmitting the torque. So power from the engine is given to the drive shaft and from the drive shaft to the differential. And even within the differential are the bevel gears, and you have different types of
Yeah,
other
I have
gears
five
like
bevel
planetary
gears
gears
inside.
also. You have it.
I have five bevel gears and I have
Huh?
an other gear, and this
Hmm.
is a transmission. Like this is another gear which I
Good.
use for a
Mhm.
linear actuator so that I can
Mhm.
use it to tug things up. Because I
And
just realized that this gear, when it
Mhm.
spins, it can actually spin another gear. So I can just take this out and connect this gear to a rotor, and we can connect it to another bunch of differentials.
Good. Let me complete
So
the
with
working.
okay, okay.
So those gears basically allows like it allows you to run on a straight road where both wheels rotate at the same speed, or it allows you to move on a curve also. Like the outer wheel rotates faster while the inner wheel slows down without losing the power of the engine, without losing the engine power. Then there are different types of differential. Like you have open differential, you have limited slip differential, then you have locking differential. All of them
Yeah,
are
the locking
like
differential, it stops the working of the differential so that both of them get 50% of the engine's power. Because
exactly
sometimes when we're doing rocky terrain, the car might accidentally go
off-road
on the
vehicles
rocky
particularly.
terrain, and the other wheel, the wheel which is in contact, cannot spin. And then the other wheel which is in the air,
Mhm.
it gets all of the power from the engine. So it
It
just spins
basically
at speed.
Mhm.
So it's of no use.
So it lacks
Then we
it
lock the
basic
differential, and then it goes.
okay, good. So it basically locks both the wheels to turn at the same speed. Like if you're running on a rough terrain, tough terrain, I mean to say, particularly locking
Mostly
differential
jeeps.
is used in the off-road vehicles, right now. Then you have the open
My dad
differential that
also
is
has he
yeah.
has locking differentials, but it's a
Oh,
normal car only.
hmm. Like common cars, most of the cars they basically have the open differential actually. That is the thing. So in simple words, you can say that differential is like a referee between the two wheels. It makes sure that both gets power but allows them to spin differently whenever it is needed. Hope you have understood it.
Yeah,
Okay,
yeah, I understood now.
good. Now we were learning in the previous class. So this is my portion. This is my portion. Oh, you are sharing the portion for your exam. Good that you have shared it, Halima. 1 minute. So nutrition in plants, nutrition in animals, heat, physical and chemical changes, electric current and its effects.
Ah, this we didn't learn.
Okay. That chapter we haven't done yet. Okay, good. Good that you let me know about it, Halima. So right after we'll be finished with this chapter, the revision of heat, we'll be taking up that chapter for discussion. Okay, now Halima. By the way,
Yes.
have you got the exam date as well? Huh? Have you guys
No,
got the
sir.
exam date? Not yet.
Not.
My
Yeah.
exam is gonna start in the middle of September, about 15th September. But we
Oh,
still didn't get the dates.
wait. Let
But
me write
about
it. Let me write that down. That's
Sir,
important for me to know. Yeah, Halima.
my exam will be on October second week. On,
October second week.
from yeah.
I don't
Okay.
know about like if it's on middle of September, but the teacher told it's about to be like that much, but it will never be before that. It'll always be after that timing.
Okay, from second week of October, Halima, your exam is going to start. Okay,
Yeah.
exam is going to start. And as for you, Ibrahim, what were you saying?
Like after the second week of September, probably at the, and till October, that'll be probably the time where my exams will start. I don't know completely, but that's what the teacher told me.
Okay, second week of September. Let's so August is almost about to end. So we have 15 days in September and we have 4 5 days here. That's almost 20 days we have in hand.
Yeah.
Okay. You still haven't got the syllabus.
No, I've got the syllabus.
I think you had told me about your syllabus earlier. Yeah, you had actually.
Yeah.
There were some chapters for which I had told you like about that matter and chemical
Yeah, I'll
formula.
tell you about chemistry. About chemistry, we have wastewater story, matter and chemical formula, as well as acid, bases, and salts.
Okay, acid,
If I
bases, and
if I'm
salt.
able to remember, that's what it is.
Okay, so you have wastewater story and matter and chemical formula. That is from chemistry.
And acid, bases, and salts.
Oh yeah, I have written that also. Do one thing, Ibrahim. Look at your syllabus and share it with the counselor, and ask the counselor to forward it to Sohail sir. Okay, na? Do this on urgent basis after the class. Do not miss it. Okay,
Yes.
so that we can begin the chapter wastewater story, and we can have one more chapter that is um, electric current and its effects too. Okay, let's hurry up and let's complete this. Yeah. So in the last class, Halima, turn your camera on. We were revising about the heat. Okay, so there are different modes of transfer of heat. Heat travels from one place to another via different ways. Okay, now via different ways. So let's learn about that. Talking about radiation. So in this we learned that heat travels in the form of waves. It travels in the form of waves and it travels in all directions. This is the way how heat from the sunlight reaches towards us and reaches elsewhere in the solar system. Right now, the heat from the sun reaches to the other planets also in the sun. Getting it? Also, in order to propagate, in order to move, it does not require a medium. If there's availability of medium, it will move in the medium. But even if the medium is absent, it will still travel. It will still move. So it means these waves can move through the vacuum also. It can move through the vacuum also. And since it travels in all directions, so it travels in all directions. So even if you were to place your hand beneath this bulb, you will feel the heat. Because normally there's a misconception that
Yeah.
heat flows only unidirectionally or flows in the upward direction. Heated molecules flows in the upward direction, right now?
Ah,
Yeah.
no, not like when it's radiation. That's about
Exactly.
water.
Hmm. That's about water or air. So even if you were to place your hand over here, you will still feel the warmth from this incandescent bulb. Okay, na? Do you guys remember which kind of filament is used in the incandescent bulb? What is it made up
Tungsten.
of?
Tungsten.
Yeah.
Tungsten. Very good. It has a
Tungsten can
very
be
high
heated up
amount of.
into
Mhm,
very high temperatures. It can be heated up into very high temperatures, which
mhm.
makes it have a glow.
Yeah.
That is why.
Basically,
It is due to the resistance.
it
Due
has
to the
high
resistance.
resistance. Good. It has high
The
amount of
higher the
resistance.
resistance, the higher the resistance, the more insulator it can be called.
Exactly,
Like
and
an
it does
insulator.
not melt at higher temperature. Okay, na? At higher
About
temperature, it does
12,000
not
degrees
melt.
Celsius.
Good.
It melts at 12,000 degrees Celsius,
Good. So
approximately.
that is the thing. Now, sometime question may be asked like, how does the heat from the fireplace reaches you? So it reaches you through radiation, right now. Like if you have left some fire in the corner of the room, so the heat from the fireplace reaches you, and that reaches you via the mode of radiation. Why not? Why it is not heating via? Why is not reaching you via convection? Because the convection current looks like this now, right? Convection current looks like this.
Yeah.
The hot air molecules moves up, it cools down and comes back. Although convection plays an important role in heating the entire room, it plays an important role in heating the entire room.
Yeah.
Take a look at this image over here. Um,
Yeah, convection happens in heaters. They heat the air surrounding them, and that air is blown towards us. They're
Yeah.
used in heating fans. It's a hot filament is put in front of the fan, and the fan blows, and then it blows the air, and the air gets warmed up due to the heated filament.
Hmm. Look over here.
No,
If
it's
there's
like
a
one in a
fireplace,
video, I think.
hold on. If there's a fireplace here, so this heat will like the entire room gets heated up. So how is the entire room getting heated up? Is the entire room getting heated up
By
due to
convection.
conduction?
No convection.
Convection.
No, because for conduction,
It's
the
with
medium
convection
has to be
only.
in direct contact. So it's only via convection. So
Yeah.
this
Because convection
convection,
is through air.
convection takes place in the fluid only, right now.
Yeah.
That is the thing. And if you are sitting in the sofa, so the heat directly reaches from the fireplace
Yeah.
towards you as well, and that is by radiation. Getting it now?
So both of them plays a big role, right?
Both
Convection
of
and radiation.
exactly both of them are playing an
But when
important
it's
role.
coming from the, but when you feel it hot in the chimney, that's via convection
Hmm,
because
hmm,
the air is getting heated up and thus
hmm,
it feels warm.
hmm. Exactly. Also, let me just explain this real quickly. Like, suppose the air in this room, in this part of the room, it is going to be cold and heavy. Yes or
Yeah.
no? That is cold and heavy. Now, these are the air molecules just above the fireplace. That is going to be light and warm. No,
Yeah.
Because it's CO2
so that is
and it's
light
warm.
and warm. So you guys now tell me, will it not rise up like this, as you guys can
It
see
will
here?
rise up and then the
Yeah,
cold
it
air
will.
will take its place and then the process will continue
Exactly. So basically,
until the
the
warm air takes the upper hand because there
Mhm.
will be because there will be warm air and when we stand up most of the warm air will be on top of us
Good.
except the floor will be cold.
Hmm. So
Yeah.
what is happening here? That the warm
So
air
the warm
rises up,
air rises up and the cold air
rushes in
just
to take
That
the
is
place.
why
yeah.
when you
Mhm.
have the marble floors, they're always very cold. But when you like go to sleep and it's going to be very warm when you keep the temperature low. But the marble is still going to be cool.
Oh, that has got to do with conduction, actually, also.
Yeah, I know. But like
Mhm.
it also gets cooled down by the help of it, right? As well, right? Or
Mhm.
does it?
It
Okay,
does.
okay.
So now we have this, like, how does heat reaches us directly from the fireplace? So since we know that via radiation, heat travels in all directions. So that is via the mode of radiation, heat reaches to you. Okay. Then one more important thing is that radiation is emitted by all the bodies. Even your body is emitting out some heat.
Yeah,
Even your
heat
body is
because
getting
we're
in out some heat.
that's why infrared is there. That's why we can
Huh.
see using infrared because it
Exactly.
detects the heat that is released from us, the
Exactly.
radiation that is released
Right now,
from us.
in the wildlife, for example, in during the night time, if you have to detect whether there's some living organism present around you, if you are in a forest, so using the infrared vision, you can actually look at which organisms are around you. Okay, na? So
It's
because
much more
the
better
body,
than like night vision goggles.
yeah, so
It's
your body emits heat. Right now, your body emits out heat actually. Okay. Now, how much of heat is emitted out by any given body? It depends upon different factors. It depends upon the temperature, surface temperature,
cold-blooded, if it's cold-blooded or warm-blooded.
warm-blooded animal.
Because cold-blooded, it relies on the temperature of the surroundings.
Very
So
good.
if it's very cold, then
Mm,
yeah, the cold-blooded animal will be
mm.
cold, and if it's very hot,
Then it
then
will
it will be
depend.
hot.
Then it will depend upon the color and texture of the surface. Particularly depend upon the color. Like the black objects, dark
Yeah,
color
black
objects,
color, and
more
it's a
amount of
lot
heat.
of heat. A lot
Mm.
of heat.
So that is the concept. Then again, we have this question like, why does a cup of hot tea become cold after some time? Because it has lost heat
Yeah.
due to radiation. It's
And
emitting
then
out
the
heat in
air
all
above
direction.
it becomes hot. The air
Yeah.
above it becomes hot, so the process
Uh-huh.
of convection.
That's a different thing, but basically, it's losing heat because of radiation. Okay, na?
Yeah.
It's losing heat
Oh,
because of radiation, and hence it becomes cold.
And the heat will be all like other there.
It will be lost into the it
Yeah,
will be
the
lost
air.
into the air
surrounding us.
around it. Good. Then there are various application of radiation. Solar heaters, they are designed to use the heat energy from the sun. Like this is a solar heater, and these are the sun's rays falling on it. As the sun's rays fall on it, so they get reflected from it now. These are the incoming solar rays, and they get reflected, and all of them are concentrated at this point. Getting it, everyone? At this point,
Yeah,
they are getting
that's the
concentrated,
point.
and that is where you are going to place the cooking utensil. In the image you can see a cooking utensil has been placed.
Yeah.
So because of the sun's, so because of the
They say
radiation,
that
it will be cooked.
it's that you should not be like so amused by about 5 watts, because
Uh,
5 watts is more than you think. If you concentrate 5 watts on a very small area, then it would be equal to a few thousand amps, which could kill you. So
what
yeah,
are you
that's
referring
why
to?
they
Like
I'm referring to concentrating energy at one point. When we concentrate an energy which looks negligible, it 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 will result in amazing reactions. For example, a man had stated that
uh,
if you have a 5 watt laser and if you are able to concentrate it on a very small amount of area, it will be
mhm.
able to give about a few thousand joules. I mean amps, and that's enough to kill you. Not
Yeah.
enough to kill you,
Also,
but yeah, it could hurt you
in order to
or
understand
hurt
it,
the
like you can take a you can take a small example. For example, like on a bright sunny day,
animals.
if you have a
Yeah,
magnifying glass and you project the sun's light
magnifying,
on a piece of paper, so the paper will burn. Okay, now because
especially
all
black
that,
paper.
yeah, because all that sunlight has been concentrated at a small point. Okay, now so thereby there will be lots of energy concentrated at this point, so it will generate so much of heat that the paper will burn. So yes, if you were to concentrate energy at a very small area, so it may lead to generation of so much of energy, so much of heat, so it can burn. Talking about the application particularly, so one application is using the solar cookers, solar heaters. Okay, now another application is that we prefer wearing light colored clothes in summer because light colors are poor absorbers of heat. On the other hand, we preferred wearing dark colored clothes in winter because they're good absorbers of heat and thus keep us warm. Okay, no? So it is important to know that there are some objects around us that absorbs heat via radiation and that releases heat via radiation also. So dark colored objects, they absorbs heats via radiation. They are good absorbers of heat. While light color clothes, they are bad absorbers of heat. Okay, no? Again, we have this question like why the radiator of the car is painted black on the front of the car. This radiator is installed in order to put the engine of the car cool. Okay, no? Because it will be absorbing the heat coming from the engine right now, and it will release the heat into the environment, into the air. So they are painted black in order to cool the engine in an efficient manner. Okay, and as you guys can see here, this is where the radiators are put in front of the car engine. This is right here is the engine and the tank, and that is where the radiator is put. It will be absorbing all the heat coming from the engine in order to keep it cool. Okay, radiators are even installed in the houses also in order to keep the house inside of the house warm. Particularly people living in the
Yeah,
uh,
I
countries
have
like
a radiator ground in my homeland. There's a lot of radiators under the floor, so yeah, it keeps it warm in the winter. We
exactly
can on it,
particularly.
but
Mhm. Particularly people living in the countries like in Antarctica, although there's very less population, very few people are living there. Okay, no? Okay. So
it's
they
very cold over
using
there. That's why we have many radiators around the home.
exactly. So we have finished this concept. Now we have some more applications. By the way, you can look here. That's based upon the concept of radiation again. So black colored objects, they absorb more amount of heat. And how are they absorbing it? So they are basically absorbing the radiations. Okay, na? And the light color clothes there reflects the radiation. They give out heat. I mean to say they do not absorb the heat. Then we have one more object that works, that
Yeah,
uses different concepts. It uses
air,
convection,
air.
conduction, and radiation in order to keep the object cool or
Yes,
hot inside.
especially the air.
Yeah.
The air, that is related to convection. It not convection. They
Hold on,
say,
hold on. Yeah,
yeah,
hold
it
on.
acts as an insulator. The
Mhm.
air inside. There are two metal layers. So the air
Talking
inside
about
acts
the
as
working of the talking about the working of the thermos flask. So look over here in the diagram. Okay, so there are two layers of the thermostat here. Okay, now the outer layer and the inner layer, that is silvered inner wall, and the outer layer, okay, now that is basically covered with plastic. Okay, now in between the outer layer and in between the inner layer, there's a vacuum. This is vacuum, the one shaded in the green color, that is showing you the showing you work showing you vacuum. Okay,
Vacuum.
everyone, right? So if a hot coffee have been put inside it, if a hot coffee have been placed inside it, so thereby what will be happening here? It
It
will
will not let the
It will
heat.
not absorb as there is air
Yeah,
which does not which is not
good
conduct
conductor.
the
It's a
heat.
bad conductor of heat.
So it's insulated, so it doesn't absorb the heat, and thus it stays warm.
Hmm.
And say and if it's a hot object, it doesn't absorb. It also doesn't cool down. So yeah.
So what basically happens here, like when we fill it with air, when we have the vacuum here, okay, na? So what will be happening? The heat from the hot coffee will not escape from the thermostat because there is absence of medium here, right? Okay.
Exactly.
Then another question is that how do we prevent loss of heat via conduction? Okay, now how do we, like, we have prevented loss of heat via convection and
convection.
conduction both here. How is it so? Like, because for loss of heat via convection and conduction, it requires a medium. Is there
Sir,
any
but
medium
loss
here?
of heat will happen with the
No.
radiation, right?
No, no, that too will be
So
minimized.
radiation.
Loss of
Oh,
heat via radiation too will be minimized in this. Okay, now
okay.
Yes.
loss of heat via radiation is also minimized in this thermos flask. Let us understand how. Remember, the inner surface of this thermos flask has been silvered. Okay, na? It is very smooth and
Ah.
shiny. Getting it? It is
So it
very smooth.
reflects.
It
Reflects.
reflects actually. Getting it
Okay.
now? So
So
Ah.
the radiation can't pass through it. So
yeah.
it
Because it
reflects and
reflects, and thus there
Uh,
is
goes
no
in
heat.
under that.
hmm. So the
I
either some
used to think, why doesn't the I used to think that when we used to keep cold water in a thermos, why doesn't it become hot even though the outer layer is metal? So shouldn't it absorb heat and then it'll
Mhm.
become super hot?
Mhm.
But then I realized it's just the silver layer.
Yeah. So sometimes we may even find the glass walls. The earlier thermos flask, instead of having a silver wall, used to have a glass in it. Okay, now I had one old thermos flask at my home. It had a glass. Accidentally one day I broke it. So the inner glass walls or either the silver walls, it will reflect the heat radiation instead of absorbing it. Like, let's say there's the heat on it, so it will be reflecting it, the heat. It will reflect the heat falling on it. Getting it now?
Yeah.
So that is,
Yeah.
so it will prevent the heat from escaping by radiation, and it will also prevent the heat from outside heat from entering in it. Okay. So
Yeah. Yeah.
conduction is minimized because the this has, first of all, has a double layer. Between the two walls there is a vacuum. Since there are no particles in the vacuum, okay, the heat cannot be passed by conduction. Because for transfer of heat via conduction, what do you need? You need particle, no?
We need.
You need
Yeah.
and you need
We need
medium.
particles.
You need a
uh,
medium.
Particle means like there's a medium. If there's particle, it means that is a
Yeah, yeah.
medium.
Particle, and if it's a vacuum, that means there's no particles at all.
Yeah. Okay, no? Then convection is also minimized right now because convection also needs a medium, like medium of a liquid or gas, so that is also absent here. Okay, so that is the working of this thermos flask. Like, then also,
But there's a
thermal
medium of but there's a medium of air.
medium of air basically means that whenever you'll be opening the lid now, when you will open the lid, so then the heat will be escaping from it. Otherwise, if you keep it, so then it will be not lost. Although it does not mean that the hot coffee or the cold coffee is going to remain hot and cold forever. Eventually, it loses the heat or absorbs the heat. Why? Because we're only minimizing it. We are
Yeah.
minimizing the loss or
It's
the
not
absorption.
possible it will completely stop because nothing
Exactly.
is perfect. Exactly.
Exactly. Then we have the concept of thermal expansion also, and there are various
Yeah, thermal
application of
expansion.
thermal expansion, and
The atoms
demerits are also
vibrate
there.
so much. the atoms vibrate so much that they move away from each other, thus making the material longer, especially for metals,
Hmm.
because they are more reactive to heat.
Good. So what basically happens when a substance is heated? Say we have an iron rod here. When it is heated, so the particles start to vibrate, right, Salman?
Yeah.
Yeah.
Particles they start to
The
vibrate.
same thing which happens to our food in the oven,
Uh, Now,
Yes.
except
when
much
we'll be
faster.
heating it more, now when we will heat it up more, it will
The
vibrate
one
faster.
of the particles will vibrate and it goes till the other and until it goes the normal, like until it from
Huh?
this
No,
end
no,
to
no.
that
It's
end it
about
will be
the
the
Hold
thermal
normal.
on.
expansion. They all go away from each other because of the too much vibration, so they move away from each other.
Hmm. So
It's
basically,
not
what
the
will be,
intention.
yeah, what will be happening? Let me draw some more particles here. Like say that these are the particles stacked in this manner. Now, when they are being heated up more, now when you'll be intensely heating it, so they will vibrate faster. The vibration will become faster. So eventually,
The
what will
frequency
happen?
of
They will,
vibration is higher.
yeah. So they will eventually break apart like this. They will start to break apart like this. Getting it, Halima and everyone?
The
So
Yeah.
this,
intermolecular gravity will decrease
it's not
because
about the
of the
gravity, but about the force that is
yeah,
going to
there's a
decrease.
force upon atoms which act upon each other, which
Mhm.
make them together.
Yeah. So
That
basically, what will
intermolecular.
happen now? This will cause the substance to increase in size. It will basically expand. Let me repeat again. The concept is that when a substance is heated, its particles vibrates and they start to vibrate faster and faster and they start to move apart. They will start to move
And it's
apart
vice
from one
versa for
another.
cooling.
Yeah, exactly. It's opposite of cooling. When you will be cooling it, they will constrict, right now.
That's
So
why
it causes
pipes.
it to
That's why
expand
pipes
eventually.
break in winter.
Yeah,
That's
in the
why pipes
winters,
break in winter, and
exactly in
that's
the
why
winter.
PVC pipes were introduced.
Hmm,
PVC pipes.
exactly. So that is the thing. Now, this thermal expansion happens in the solids, liquids, and gases. In all the mediums, it happens. Okay, now particularly less amount of expansion is seen in the solids. Okay, now less.
Mostly in gases, maximum in gases.
Mhm. Maximum in gases actually. Good.
Because the
Liquids.
intermolecular attraction is very low, so it's very easy to make the atoms move away from each other.
Good. While in the gases, now we are seeing that the expansion is maximum. There's maximum expansion in the gases. Okay, that is the thing. Now further, like you will see that the electric wires now they will sag in summer. What happens like they expand in hot wires. Okay, na? So they are kept slightly tight in the winter. Okay, na? They are kept slightly tight in the winter. Since they will be expanding in the summer season, okay, na? So we basically keep them a little bit loose so that they don't break away. While in the winters, they kind of tightens up. Getting it, Halima? In the winters,
Because of the effect of the thermal expansion.
exactly. Then we have the example of railway tracks also. So gaps are
Yeah,
left between the railway tracks on purpose. You will find that gaps are left between the railway tracks on
yeah,
purpose
in
to
modern
allow
railway tracks.
the expansion in the hot weather. Okay, no, that's the thing. Also, suppose in winters, what happens if the metal lids of the jar they get tightened, so you can lose them by heating, right?
Yeah, heating it
Yeah.
up. Yeah. Also,
Also, the
with the same
metal.
thing they do to tires, they just take first they
Hmm,
put it in cool water so it contracts. Then they put the rubber on it, and then they heat it up. They heat it up as much as they can, and it fits neatly inside the rubber.
hmm. So in like in the carts, this kind of wheels were used, right? And carts pulled by the bullocks or the horses. So we have a metal rim around this wooden wheel. In order to fit the metal rim around the wooden wheel, first this metal rim will be heated so that it expands, and then it will be placed over the wooden wheel. Okay, while it is placed, water is poured over it so that it constricts, so that
Yeah.
it tightens over the
Yeah. It
wooden
I
wheel.
think
So that is how it
No,
works.
no, no. Cooling makes it smaller, right?
That is what tightens means. Na? It is if it is
Ah,
tightening, so it means it's becoming smaller in size.
So then that is the time where we can add more hot water so that it tightens up, like
No, why you'll
loosens
be
up a
adding the
little.
more hot water on it then? You have to add cold water on it so that it gets a tight grip over the wooden wheel. Okay, now?
No, but if we if we add hot water on it, then it will increase in size, and thus there will be more grip.
No, no, no. That is not the thing. Basically, what I said that
It will break, right? It might break. That's
hold
why.
on. See that this is the metal ring. Okay, and you have to fit it over this wooden wheel that is smaller in size than it. Okay, no. So
Oh, when
first
it's
of all,
smaller in size. Okay, okay.
yeah, the
I
wooden
thought the
wheel that
wooden
is
wheel was bigger and the metal one is smaller, and we just have to make it fit inside the bigger wooden wheel.
basically we have this wooden wheel that is a small in size. Let's say now we are required to fit it. Okay, right? It is of the same size. Let's say this metal rim is of the same size. Let's not talk about a small or big, otherwise we'll get confused then. Say we have the metal rim that needs to be fitted over it. Okay, now but let's say it is shorter. It is slightly shorter. Let us say that we are unable to fit it properly. So we are going to heat it. Okay, now after heating it is going to expand. It will expand in size. Now you will place it just above it. You're going to place around it, and then you will pour cold water all over it. You will place the cold water over it. Then it is going to shrink in size. Okay, now? And as it will be shrinking over the wooden wheel, so it will be getting tightened over it now. It will have a strong grip over it.
I thought you were talking about modern wheels because uh, it doesn't happen in modern wheels, but I've heard my sister talking about it, so I thought it also happens
Mhm.
sometimes,
Oh,
but it doesn't, right?
that's a different concept of it. Okay. Okay. Now, if we have one mark question, so how long should be the answer? Let's discuss that. So
Sir,
first
can I
question
say
is
the
define
question?
heat. Yeah, Halima, say it.
Sir, can I define heat? Sir, can I define heat?
Hold on. Halima, you define it first.
Sir, heat is the transfer of energy between objects with different temperatures.
It's a transfer of heat. No, rather you
Yeah.
should be
Sir,
saying
can I tell?
form of
Sir, can I
Sir,
energy.
tell?
I said,
Heat
sir,
is
I
a
said,
form of energy. Heat is a form of energy present in almost all forms of matter. It is transferred from matter which has a high temperature to matter which has a low temperature,
Okay.
and it is measured in joules. And calorie was the older unit.
Hmm. No, Salman.
Sir, heat is defined as a form of energy that is transferred between objects due to a temperature.
Transfer between objects. And what did you say?
Due to
Due to
temperature,
a
due
temperature.
to different
No,
temperatures.
not. You should be saying due to temperature. You can say due to temperature difference. That would be correct, but you should not just say due to temperature. Okay.
Due to variations in temperature.
Yeah. Also, Halima, in your definition, what was the first line you said? It is a transfer of energy. You were saying, right,
yeah.
Halima? But you should be saying heat is a form of energy, right?
Okay.
Okay. And Ibrahim, you can just skip it a bit simple, or you can add about matter also. But simply, it's a one mark question. So what we will write that heat is a form of energy. Okay, this is the important line. You should not miss it. So heat is a form of energy
Sir,
that is, yeah,
sir, can I tell the answer for a
yeah,
second question?
yeah. Tell me.
Sir, Kelvin.
That is Kelvin. Good. So heat is a form of energy that is
Yeah,
transferred.
Kelvin, yeah, and the rest of them are just yeah.
Hmm.
But what
Form
about
of
joules?
that is the unit of heat actually. Heat and temperature, they are slightly different thing. Na? Heat is a form of energy. Temperature is the measurement, na? Right? Measurement of the
And the
hotness or
SI unit
coldness.
of temperature is Kelvin. Oh, okay. He's talking about
Yeah.
the second question.
So heat is a form of energy that is transferred from a hotter object, a hotter body rather we can say. Write
Poor
down this
body.
definition. Very good. Hotter body to a
To
colder
colder body.
body. Colder body, but hold on, it's not finished yet. Colder. Oh, sorry. Colder body, I mean to write. Colder body due to difference in their temperature, right?
Yeah.
Hmm.
Yeah.
The hotter body will the colder body will conduct more heat. Like if there are two bodies and one of them is cooler than the other, then the cooler one will conduct more heat from the hotter body.
Hmm. An SI unit of temperature
Is Kelvin.
is Kelvin.
Sir, can I tell the definition of temperature?
Yeah, you can, but write down this also. Okay,
Okay,
no,
okay.
do not miss
So,
writing it.
the definition of temperature is it is the degree of hotness or coldness and is the measure of it is the measure of the degree of hotness or coldness of an object. In
Hmm.
short, the measure of heat.
Good, good. Finish writing it down quickly, everyone.
Okay.
Sir, SI unit full form is?
SI stands for System International. Okay,
Oh,
na?
Yes, system. It is first said in French, but then it was converted into English.
They're like in French, Système Internationale. Système Internationale. But we basically write it down, read it as international system.
Yeah,
Getting it?
it's more simple.
Yeah.
sir, I'm done.
Then others also hurry up. The full phrase goes like Systeme International de Unites, kind of like
System de
that.
la International.
Yeah.
System de la International. Yeah, yeah. It's
Mhm.
very hard to pronounce French. I
Mhm.
myself don't like French because it's too hard to pronounce.
Yeah,
But
I like
uh,
find it a bit weird language.
yeah, but it's not the hardest. But Americans feel it the hardest most. They think it's the
Mhm.
hardest language, but Arabic is much harder.
Mhm.
And we have Arabic here, that's why. But I still feel it easier for some reason.
Mm. Arabic is actually, it's not that Arabic is difficult. Okay, actually, it's the most
It's
beautiful
just the verbs.
language.
It's
Yeah,
just the
if
verbs.
once you have command over the grammar of the Arabic, now then it will become
Yeah,
very easy.
then you're
Sir,
very good in then you'll be very good
sir,
in Arabic.
Yes, Salman,
It's all about
sir,
knowing the
Arabic is
grammar.
the second hardest language.
it's the second hardest
No, it's
language.
not the second hardest language. It's the third hardest language. The second hardest language is Norwegian.
Then which is the hardest language as per you guys?
The
Chinese.
hardest language is the Chinese, and it's known
Yeah.
as
Mandarin Chinese.
yeah, Mandarin Chinese. They say that everybody is going to say Mandarin Chinese in the future.
Mm.
But
It
yeah,
it
because
it's
China,
actually because of the tones and like probably there are
yes,
thousands of
it has many
characters in
tones and it
Chinese.
also has a lot of alphabets. It has a
Hmm.
lot of alphabets.
What I'm saying now,
And
like there
their
are
tone and
thousands of
structure.
characters. Alphabets in
And
context
it's
of Chinese
like
refers to the characters that's there.
and it's not very appealing to a person
Mhm.
who's used to English because they're in a very weird way.
You're
Japanese
finished.
is almost the same.
Yeah, you guys
Yeah.
finished with this?
Yes.
Okay, now we have a 2 marks question. Question is like, why is water not used in a thermometer? Suppose this is the question. Another question is state two differences between clinical thermometer and laboratory thermometer. Okay. Yeah, Ibrahim.
Sir, can I try the third
Yeah,
question?
yeah.
Okay. The reason why water is not used in a thermometer is because it doesn't thermally expand a lot, unlike metals which expand to the contrast which we can measure. For example, if we put water and heated it up inside a thermometer, it would not be close to enough to go to reach even a little higher, as it would need a very high temperature. And even when we add it at that temperature, it would evaporate. Thus, metals are used such as mercury. Uh, and nowadays we use other liquids which can expand on heat.
Okay, but we have to keep in mind that this question carries 2 marks weightage. So we will be answering it,
Sir,
it accordingly. Yeah, Halima, you answer now.
sir, water is not used in thermometer because water's boiling point is 100 degrees.
Hmm.
But if we put water in the thermometer and we test a person who is like sick, and for example, his temperature is above 37 degrees. For that, we need his temperature to be above 100 degrees, but that is not possible. So that's why water is not used in thermometer.
I mean, it is possible. It is basically possible. Sometimes, due to really death fever, close to death, it can happen.
Yeah,
But it's technically of no use because it's literally about 1 in 7 billion. It happens. You get such a fever, and
Hmm.
in contrast, it's only for people like that, and it's not even accurate.
See,
exactly.
first of all, yes, Salman, what about you?
Oh, sir, I got your point. It is because we have already been accustomed to use metals which are great conductors and thermally expand even at low temperatures, unlike water which doesn't even quite expand at a high temperature.
You see, the thing is that like mercury, okay, like mercury and alcohol, okay, like they expand uniformly when they're heated. Mercury and alcohol, they will be expanding in a uniform
Equally.
manner, in a proper manner when they're heated. So it will give you precise measurement. But water, it does not expand in a uniform manner. Okay, na? Especially if the temperature is like 0 degrees Celsius, 4 degrees Celsius. So at that temperature, it will start to freeze now, right? Getting it? Also, it has a small range of temperature measurement. Let me write down the bullet first
The
important points here.
uniform manner in the sense like
Means that sometimes it will like at different temperature it will be expanding in a different manner. Like at if the temperature is 0 degrees Celsius, the water will freeze at that temperature.
And it will
uh,
expand when it
And then
freezes.
student,
if the temperature,
what about metals? They also like expand, right? And when it is like above 100
No, they
degrees.
don't expand when they freeze. Water
hold on, hold
expands
on,
when it freezes.
hold on. The thing is that only some of the metals are used in the thermometer, particularly metals that exist in the liquid state at room temperature, and that is mercury. One important thing is seen about the mercury is that it expands in a uniform manner. Now, what does uniform expansion mean? Uniform
Means that
expansion
if it
means
is
that
4 degrees Celsius, it'll increase at the same amount as it did from 0 to 4,
hmm,
like
basically
that
means
way.
that if someone's body temperature is, let's say, 35 degree Fahrenheit, it's a 35 degree Fahrenheit. Mercury has, let's say, shown this much of expansion. Getting it? Try to understand this with some example. Okay, na? If the temperature goes
Ah,
36 degree Fahrenheit, then the mercury expands slightly more, this much. Okay. Then let's say if it's
so it's
37
very
degree
reactive to
Fahrenheit,
heat. It's
then
reactive to heat.
yeah, then it expands like this. So every time it is expanding in a uniform manner, like this much of expansion here, this much of expansion here, this much of expansion here. Let's say here it expanded just for explaining it, for the sake of explaining it. Let's say here it has expanded by 1 millimeter, here by 2 millimeter, here by 3 millimeter. This is not
So it
accurate, but
expands
just for this,
uniformly.
yeah,
Okay.
just for
Okay.
the
Now
sake of explanation, I am writing it down, but it does not hold any accurate meaning. Okay,
yeah.
so it is expanding in a uniform manner. And even if there are two persons, like person A and person B, so for person A also, this much will be the expansion. For person B also, having this much of body temperature,
Yeah, it could
this
be
much will be
different for
expansion.
different people.
No, it will be
It's
same for different people. If two people are
water,
having the same
water,
temperature,
water is very inaccurate. At the same
uh,
temperature, it might increase, but at the
Yeah, it
same
might
temperature, when you do
expand
it
or
again, it might decrease more.
the thing
yeah.
is
It's
that water.
unpredictable. It's unpredictable.
Mhm. The thing about the unprediction is that it can. Basically the thing is that it will freeze at 0 degrees Celsius, right now.
It's not
No
built for
matter,
this.
yeah,
That's why.
it freezes at 0 degrees Celsius, it boils at 100 degrees Celsius. Okay, no? So it can
And that is
only
not what
measure,
you want.
it can measure only temperature between this range, and it is not useful because thermometers need to measure very low as well as very high temperature. Okay, no? So let's write down the answer to this question. Okay, now also there should be an introductory line for this, since it's a 2 mark question. So water, why is water not used in a thermometer? So we will write down that water.
Water is not used in thermometers because it's a very in unpredictable substance, and as well as expands in freezing and contracts while heating.
Hmm, because of several reasons, which are as follows. So this introductory line should be written. Then you will list down the different points. Okay.
Bullet points.
First point we are going to write down
Should be
that.
in bullet points.
Yeah, it should be in bullet
It
points
is
like this.
very unpredictable.
This one point no one is talking about, that water is actually colorless now. It's colorless and
Yeah,
transparent, so it will become difficult to see it inside the capillary tube of the
yeah.
thermometer. So
Uh,
first thing we should write down that water is transparent. Basically transparent, and it is simply colorless,
and it is thus hard to see.
hence cannot be seen in capillary tube.
Clearly.
Okay. Another problem with it is that it does not expand uniformly. Okay, na? So
It does not expand uniformly and expands when freezing and contracts while heating.
hmm, so it does not expands uniformly like mercury. Write it down quickly. Mercury and alcohol. Okay, now mercury and alcohol shows a uniform expansion. So this
Yeah.
irregularity in the expansion of water makes it unreliable for accurate measurement of the temperature. Okay. So further we will write down that it freezes at 0 degrees Celsius and expands, particularly we will write down
At 100 degrees.
boils at
One.
100 degrees Celsius.
100
Okay,
is
na? So these are the problems with it. Okay. Also, even alcohol that is used in the thermometers, not like in the maximum and minimum thermometer. So colored alcohol is used there. Okay.
Yeah.
Write it down quickly. We have one more question to discuss. That is state
Uh,
differences between clinical and laboratory thermometer. Salwan, you answer the second question, fourth question first.
Then can I try answering, sir?
Yeah, you guys will also be answering it.
Yay. Finished, sir.
Finished? Okay. Yes, Salman. What are the differences between clinical and laboratory thermometer? Keep in mind that this question carries 2 marks. So minimum
Yeah.
2 to 3 differences should be there in your answer. Minimum of 2 to 3 differences. Salman, am I not audible to you? Turn your camera on. Answer the fourth question.
Two main differences are there.
Answer while
Temperate-
keeping your camera on. Turn your camera on and then answer. Yeah.
Sir, the two main differences are uh, temperature range,
Repeat again.
temperature range,
Okay. Elaborate it.
Ooh.
and the presence of kink.
Good. Elaborate on the
Sir,
first point. Ibrahim, hold on. Let him finish first.
okay, sorry, sir.
Elaborate on the first point, Salman.
So I didn't think about that. I didn't think about about temperature range. I was
Hold
just
on, hold
thinking
on,
about that.
hold on, Ibrahim. Yes, Salman, elaborate on the first point. Do you remember, or should I forward the question then?
What's up?
Do you recall the temperature range of the clinical and laboratory thermometer?
I remember the temperature range.
Okay, Ibrahim, you answer now.
It's, I guess, 37 degrees to 98 degrees.
For the clinical, you are saying? No,
Clinical, I think, yeah.
no. Halima, do you remember this one? What's the
Sir, I
temperature
don't.
range?
No,
Yeah, tell me.
I know for laboratory thermometer, it's
Hold on, Ibrahim.
negative 10 degrees to 110 degrees.
Yeah, that's correct. Halima, answer for the clinical
Sir, for
thermometer.
clinical
Can I?
thermometer, it is 35 degree to 42 degrees.
Yeah, that is from 35 to 42. As you guys can see here, that's from 35 to 42 degrees Celsius. Okay, good.
I know
Yeah, you
something
guys
from you.
done with the answer of this question, no?
So can I do the fourth question? Can I say it?
Yeah.
Uh, the following the two differences between clinical thermometer and laboratory thermometer are as follows. Um, Clinical thermometer is used by doctors to measure the temperature of patients, while laboratory thermometer is used in laboratories to find the temperature of chemicals and other stuff. And what's it called? Yeah, the clinical thermometer has a kink which prevents the backflow of mercury, making it very easy to read. Making it easy to read. Uh, laboratory thermometers, laboratory thermometers
Does not have a
do
king.
not contain a kink, as it is not necessary to remove it, as we can leave it there and read it.
Good. And you can add one more difference between them
Sir, can I?
about
Yeah,
the.
one more difference. One
Yeah.
more difference is that they use that modern clinical thermometers are digital, while
No,
laboratory thermometers.
that's not the difference. That's not the difference.
Sir,
You
can
should
I?
have mentioned about the temperature range. Yeah, Halima, now you also answer.
Oh,
You're on mute, Halima.
Sir, the temperature of clinical thermometer is 35 to 42 degree, and laboratory it is for minus 10 to 110 degrees Celsius. Clinical, they have kink in it, but laboratory, they have no kink. Clinical, it can be used for body temperature, but for laboratory, they cannot. It is not perfect to use for body temperature.
no, it's like
Um,
there's no such thing as perfect to use. It is not built to use for measuring body temperature.
It is not suitable. Yeah.
yeah, it is
Yes.
not.
Okay, now. Also,
And
continue.
clinical thermometer, clinical thermometer. Yeah, clinical thermometer cannot be used for a very like it cannot be
High
used for
boiling liquids.
hot boiling liquids, but for
Okay,
but
that
for
point was
laboratory.
covered. That point was covered when Ibrahim said that clinical thermometers are used by the doctors in order to take the
Oh,
temperature of the body, to take
okay.
measurement of the body temperature of the patients. And the laboratory thermometers, they are used to take the measurement of the chemical liquids that are particularly used in the laboratory. What is the common thing between both of them? Is there anything common between?
The common thing between both of them is that they're used to measure temperature.
There's one more thing common in their construction, that both of them contain
The capillaries. They contain a
capillary.
capillary
No,
tube.
they both contain mercury.
You're saying that
No,
both
a
contain
laboratory
mercury.
Both
thermometer
of them
usually
contain
doesn't contain
mercury.
mercury. Clinical thermometer nowadays doesn't contain mercury. It is digital. We're not talking about that. We're telling that
Oh, no,
We are
they
talking
both
about
have a
clinical
capillary tube.
and we are talking about clinical and laboratory, but not about
maximum and minimum thermometer.
yeah.
Actually, the maximum and minimum thermometer usually contains what we call as alcohol, but still we
Yeah,
find that both laboratory and clinical thermometer contains mercury in it. Okay, na, Ibrahim and others.
Sir,
But
Ibrahim is
what about
talking. He's talking about
Uh-huh.
digital thermometer.
yeah, digital
Oh,
clinical thermometer?
that's a different thing. That's a different thing. But we have to answer in the
Why
context
are
of
you
the
talking
question and
about
the
that
chapter.
then?
Like laboratory thermometer and the clinical thermometer. Traditional clinical thermometer, particularly clinical thermometer, that like this one, it contain mercury in it, right? I'm not talking
Yeah,
about the
that
modern.
containment.
This one contain
Modern,
mercury.
modern is the digital thermometer.
Yeah, modern operates
Yeah,
on the
those are
cell.
much safer.
Yeah,
Yeah,
mm,
dry set actually.
dry cells, particularly that dry circular cell.
Which are very sensitive to heat and
Mhm.
can very accurately display it on a small
So
LCD.
good. So we have some more questions to do from the chapter. Then we'll be. I'm thinking to start with that chapter in the next class.